Alright, welcome back to Algebra on Functions. After we learned about the operations of functions, we need to find something important for any function, which is the domain. So we learned about how to get the domain of a singular function, a quadratic function, rational function, linear function. Today we're going to learn about how to find the domain of two combined functions. So in order to find the domain, we have to define the domain of f plus g, f minus g, f times g or f over g is the intersection between the domain of the individual f and g. Meaning that if I have the domain of f is all the real numbers, so this is f, and g is from 5 to infinity, so the domain is of f plus g is from 5 to infinity, only that part. Why? Because this is the intersection of the domain of f of g, f and g. Alright, let's get an example and to find the domain of two functions together. We have to find something and watch that when I have a domain of f over g, I have to consider that g of x cannot be 0. So I have to exclude the value of x that makes g of x is 0. Let's get an example about that. Okay, I have found the domain of f plus g when f of x is the square root of x minus 3 and g of x is 1 over x minus 5. Okay, when I have a square root, whatever under square root, the radicands cannot be negative, which means that for f of x, x minus 3 must be positive or 0. It's greater than or equal 0. If I solve for x, the inequality, I'll get x. I add 3 to both sides, so I get x greater than or equal 3. Okay, now I'm going to graph that on the number line. Make the number line here, and 3 is greater than or equals 3, so 3 is open or closed? Closed. Alright, I'm going to go to 3 here. Let's go 3, and closed. And then everything greater than 3, so here is the domain. Okay, so the domain here I can write it down as 3 and infinity. So what about the domain of g of x? G of x is a rational function, meaning that the denominator cannot be 0. So if I have a value of x that makes the denominator 0, I have to skip this value. Okay, so x minus 5 cannot be 0, so I solve it for 0 and find the value of x. So if I add 5 for both sides, I get x equal 5. And this point is the unhappy point. Alright, so let's again do the same thing. I graph the number line and I go to 5, but this time I have to skip 5. So 5 would be an open circle, and everything in the left is okay, and everything in the right is okay. So here is the domain, is fine, and for the other side of 5, the right side is also okay. So now the domain here is from negative infinity to 5 union 5 and infinity. And I'm pretty sure that it's nothing new for you up to here. The new thing is the next step, is the domain of f plus g of x. Okay, so I'm going to graph a third number line, and I'll look at here. So right below 3 is not on the domain of f of x. So if I go with 3 here, anything below 3 is skipped. I'm going to go for 3 here, and 3 is included in both in F and G, so I'm going to make 3 closed circle. Okay? Now let's move to the right. I'm going to go okay from 3 to 5 is fine. However, 5 is skipped here, so I have to skip 5 here too. Okay? So, and this is shaded. Right after 5 is included in both, so I have to include that part. Again, right before 3 and f of x is not included, so I cannot include it here because I'm looking for the intersection. And then from 3 is included in both the domain of f and g of x, so that must be included in the intersection. But here 5 is skipped in g of x, so I have to skip 5 in the domain of f plus g. And now we can write the domain. So I start from 3, close set, to 5, and is 5 open set or close set? This is circle, open circle, so open set parentheses, and then union 5 to infinity. And I hope that works, and see you in the next video. Thank you.